This video is for Unit 13 on statistics, and today we're going to be looking at Lesson 2, which is on normal distribution. So in the real world, your data is not always going to be pretty and perfect. It can show a variety of relationships. So data can be distributed in different ways. So if you look at the three graphs up top, you'll notice that this one is kind of skewed to the right, this one is skewed to the left, and then this one, the data is all over the place. So we're going to look at what's called normal distribution, and I'll define that for you here. So normal distribution occurs when data tends to be around a central value with no bias left or right. So some examples of things that tend to be normally distributed are heights of people, errors in measurement, blood pressure, or marks on a test. So what we use when we're looking at normal distribution is something called the bell curve. It looks like a bell. So it's evenly distributed. So your mean, median, and mode all lie on this central line, and it has symmetry. 50% of the data lies below that mean, median, mode. 50% lies above. And a normal distribution bell curve follows the rule of 3. So let's look at the first one. Hold on one second. Just getting this adjusted. So before we go over actually the rule of 3, I want to define something called standard deviation. So standard deviation is tells you how spread out the data is. So just give me one second. So standard deviation how spread out the data is. All right, I'm going to define a few more things for you right here. So the second thing that I want to define here at the bottom of the sheet, and then we'll read through the rules of 3, the number of standard deviations is also called the standard score. Sigma, which is a Greek letter that looks like this, or probably most commonly, it's called a z-score. So that's the number of standard deviations. So remember, standard deviation just tells you how spread out your data is, your numbers are. So let's look at this rule of 3. So the rule of 3 starts off with 68% of the data falls within one standard deviation of the mean. So it says plus or minus one standard deviation. So 68% lies in this shaded area right here. All right. That means 34 is here and 34 is here. Okay, 34 is above the mean and 34 is below the mean. 95% of the data falls within 2 standard deviations of the mean. Remember, that's plus or minus 2 standard deviations. So half of that's going to be over here and half of it's going to be over here. And then 99.7% of the data falls within 3 standard deviations of the mean. So that's getting pretty close to 100% of the data lies within 3 standard deviations of the mean. So what I want to do now is I just want to break that down a little bit further, and just do a nice bell curve for you, which you'll be able to do if you'd like. So let's put those notes aside and just look at another blank bell curve here. Sorry, this is a little bit tricky because you can't see the whole thing at once. All right, so first of all, I'm going to label the bottom with standard deviations. So right here in the center, you have your mean. We normally label it mu. It's a Greek letter. So that's your mean. This would be -1 standard deviations, -2 standard deviations, and -3 standard deviations. Over on the other side, we have 1 standard deviation, 2 standard deviations, and 3 standard deviations. All right. So remember, the between the first standard deviation plus or minus first standard deviation is 68% of the data. All right. So that means that there is 34% below and 34% above that mean. Okay. So the second 2 standard deviations out is 95%, which is going to leave 13.5% right here and 13.5% right here. Okay. Then the third one, 3 standard deviations out, we said it's 99.7. We're just going to say it's 99. Whoops, I meant to go out to the third one. You can't see that, but I am going all the way out to the third standard deviation. So we're going to say it's 99%. So that's going to make 2% fall right here and 2% fall right there. And then what's left is 0.5% on the left of 3 standard deviations and 0.5% on the right of those 2 standard deviations. So that's just another bell curve. And just as a reminder, 50% of the data lies to the left of the mean and 50% lies to the right. So now back to our notes. We're going to do a few examples here with standard deviation and normal curve. So if we look at our first one, it says to, let me adjust that, sketch a normal distribution curve for a set of data with a mean of 45 and a standard deviation of 10. Label 1, 2, and 3 standard deviations from the mean. So we do our little bell curve shape, our little line here. Right down the middle, we know that's 45. So our standard deviation is 10. So if we go 1 standard deviation away, that's going to put us at 55, 2, 65, and 3, 75. Below, 35, 25, and 15. And there's our normal curve. All right, so here's the second example. So sketch normal distribution curve to represent the following. So our mean this time is 30 and our standard deviation is 3.5. So 30 goes in the middle, and then 1 standard deviation would be 33.5, then it'd be 37, then it'd be 40.5. Below, it's going to be 26.5, and then 23, and then 19.5. All right, the next problem says a set of data has a normal distribution with a mean of 62 and a standard deviation of 6. Find the percent of data within each interval. Sorry, the question goes off the page a little bit there. So let's first of all just create our normal curve here. So we know our mean is 62. So we're going to put that in the middle. Standard deviation is 6. So that's going to be 68. And then 74. And then 80. And then we've got 56, 50, and 44. All right. So from 56 to 68, that's one standard deviation on either side. So we know from our rule of 3 that's 68%. All right. Greater than 50. All right. So we know that there's 2% here and 0.5% here. So we're just going to do 100 minus 2.5 to get 97.5%. Less than 62. Well, that's just everything to the left of that 62, and we know that's 50%. All right, from 62 to 72. All right. So we know from 62 to 68, that's 34%, definitely. All right. Now, if we want to go from 68 to 72, that's 4, whereas our standard deviation is 6. So 4/6 of this 13.5%, because we know there's 13.5% right here. So we're going to find 2/3 of that 13.5%. It ends up being, you're going to have 34% plus 9%, which will get you 43%. All right. And then our last example. Okay. So it says, in a university lecture class with 174 students, the final exam scores have a mean of 68.5 and a standard deviation of 7.3. The grades in the exams are all whole numbers, and the grade pattern follows a normal curve. Find the number of students who receive grades from 1 to 2 standard deviations above the mean. So before we get started with that, we'll make our standard, our normal curve. So 68.5 is our mean, and our standard deviation is 7.3. So one standard deviation above is 75.8, and then you're going to have 83.1, and then 90.4. And then below will be 61.2, 55.9, maybe 53. Hold on one second. And then, sorry, that should be 53.9, sorry. And then 46.6. All right. So we're going to find the number of students who received grades from 1 to 2 standard deviations above the mean. So 1 standard deviation to 2 standard deviations above the mean, remember from our nice little handy dandy bell curve, that's 13.5%. Now we know the total number of students is 174. So you can change your percent to a decimal and then multiply by 174, and it gets you 23.49. So we're going to say 23 students because we can't round a student. And then the last one, we're going to find the number of students who received grades of 61 or below. So right about here, we're 61.2. Okay, 61 and below is going to be in this section. So you've got your 13.5%, your 2%, and your 0.5%. So if we add up 13.5 plus 2 plus 0.5, we get 16%. So we're going to do 16% or 0.16 times 174 to get 27.84. So we would say about 27 students. And that's it for normal distribution.